seen that. But to compare those, you want to have the same base. All right, running to the next stuff. So properties of these. Dang it, it's like I'm duplicating things today. I just wrote this. So, yeah, sorry. I got to look ahead sometimes. Sometimes I just get carried away. Yeah, so those are some nice rules. Log base b of 1. Things that we just discovered in the problems we did. Kind of nice to know. There's another one here, and these are not magical properties. It's just that if you raise b to the y, it's going to be b to the y. If you keep that idea of conversion, it's just, but if you do the log, now this is actually the better way I like to think of this one here. I'm going to give you guys a different way to look at this property. Let's call this property 3, if you want to call it that. There is, if you take log base 10 of 10 to the y, here's the deal. That if you take a log of the same base, I'm going to change colors here, of some base in an exponent, you can actually think of them as canceling each other out effectively. So the log base 10 of the base number 10, it's like they cancel each other out, and you end up with just y. And so if you can think of it, a log is the inverse of the function that undoes bases of certain exponents. If I do it with e, it happens the same way. So we'll do natural log. By the way, natural log is log base e. The log base e of e, which is actually e to the first, I told you before earlier today, I said, hey, the log of e or the natural log of e is just 1. Well, here's the rule that goes with that. The log base e, which we rarely write as ln, so I should probably put that there so you don't think I'm making this up. This is ln we're talking about. Okay, that's log base e. Get my highlighter going. The log base e of e, that little chunk right there, oh, too far. I wanted to do the log base e. I can get my highlights, I promise, I promise. Yes, yes. Those two are inverses of each other. They cancel each other out, and you just get 1. So this one right here is just y, and this one right here is just 1. The way we write the log base e, we don't write it that way. We write natural log of e to the first. We say these guys can't, it's just 1. So if you're going to take the log of some base of the same base right next to it, this b, those dudes will cancel each other out. So these guys will cancel each other out, and you're left with just that exponent. That helps when I'm solving through things. When I know that I'm doing the same base and I take the log of that base itself, I know those cancel each other. We'll use that later on when I show you some solving stuff. Same thing. The flip side of that is if you take base b to the power of log base b, they cancel each other out there too. So I'm not going to make a big stink out of this one. Check it out. Some base b to the log of base b in the exponent, it's like they cancel each other out, and you just get x. Okay, so the idea is that logs of certain bases, a base, cancels to 1, by the way, with same base, with base. And that sounds crazy, but as we go along, keep percolating what that means to you. Logs of a base cancels with the base when they're applied at the same time. Okay, so the examples below, you got this one? Look at this, look at this. We got it right below. 5 is a base, and I'm doing it to an exponent of log base 5. Guess what that 5 and log 5 are going to do? Yeah. Sayonara, log and base. Hasta la pasta. Excellent. So next one. Hey, so you just get x. 3 to what power is going to give you 0? You don't need anybody to tell you that one. You got it. 3 to the what? 3 to what is going to give you 0? Is there anything I can raise 3 to and get 0? 3 to the first is 3. 3 to the 0 is 1. 3 to a fraction is like a radical. Oh, no, you didn't. Doesn't happen. You can't raise 3 to any power and get 0. You guys know what an exponential graph looks like. Any b to the x, I don't care what it is, if I graph that thing, it never does 0. It just goes, remember it hovers above there? Goes through 0, 1 right there. That's good. So it's not going to happen. So just watch out. Those are some really good properties happening right there. Did I hit them all? Here I am skipping again. Darn it. But it's good. It's all related. I meant those are all tied together. It was meant to be. Kismet. Okay, back to the drawing board. What do you guys remember about taking a log of a certain base of el mismo base? Annihilate each other. That's a good one to keep out for. Log base c of a base, actual exponential base of c, means they're gone. They cancel each other. I just get the 3. Done for. The next one, if it's not one of those common base kind of deals, I like to put in the x like I was doing before. 1/2 to the what power gives me 4 again? I don't know. So I go 1/2 to the x equals 4. This is a tricky one, isn't it? 1/2 to the x power equals 4. Do you know, this is one of those where you want to get a similar base. Like I might want to rewrite them so that there's some number to the an exponent. I know I can deal with 4 is something 2. It's 2 squared. Now can I get 1/2 x to be 2 to the something something? And if you remember, yeah, that's 2 to the negative x. You flip it over. Be flippity flip. So that's, now I got same base of 2. Oh, negative x has to equal 2. Okay, yeah, I got that part. So x is negative 2. That's a nice, that's tricky. Tricky Ricky. I think we nailed the evaluating ones. There's a lot going on in there, and it's a lot to remember. Really, it comes down to, if you can, have you noticed that ultimately you can get by almost exclusively by knowing that one little trick that I showed you, which is take the base to the exponent over here, this power, and it's equal to this value you're taking the log of. If you remember that, that's the foundation of all of it. What we're trying to get at, though, is there's some shorter or quicker ways to evaluate it as you get more experienced. So keep your eye open for ways to make your life easier. So common logarithm versus the natural logarithm. Okay, the common logarithm is log base 10. I like this, pink. Natural logarithm is log base e. We don't write it that way, though. We just write it ln of x. It gets its own, it's just log natural ln. That's it. Now, the big to-do is, now, log base 10, we tend to use it because we use the base 10 number system. So there's value to using it in our system of base 10 numbers. If you guys go into computer programming and binary stuff, log base 2 is really helpful because everything binary is in base 2. The whole 0, 1 combination thing, that's all base 2. The natural log base e, its properties are just, they're kind of crazy. E is just so magical. We saw that yesterday with the money. Exponential growth. We just kept compounding over and over again, and E magically appeared. Things that grow naturally. Well, E has many more powers than that. One of the cool things is in calculus, since this is a pre-calculus course, E to the x is an awesome graph. And when you take the derivative of E to the x, that's something we do remember to find the slope on of a tangent line at any point on a graph. We take this thing called a derivative. It's not hard to do. Well, E to the x, its derivative, it's the only one that does this. Its derivative is itself, E to the x. The derivative of E to the x is E to the x. And everyone in calculus loves when you have a derivative with E in it, because you're like, yes, this one's easy. Got it. And it's because of its beautiful properties that works that way. That's one of many cool things about it. So we love these two types of logs. I use natural log more than I use log base 10. because I think it's easier. ln, it's also the easiest button to find of the logs on your calculator. You name it, it's awesome. Okay, so if you want to do these with a calculator, well, that's no problem. We get out of this thing. So do I have my calculator up? My TI? TI. Oh, good. We hit a good spot there. I'm going to stop this, pull up my calculator, and start again. So